We hop in them every single day without even thinking about it, right? They lift us, they lower us. They're kind of the silent workhorses of our modern world. But here's the thing. The simple elevator is anything but simple. In fact, getting it right is one of the most complex and critical engineering puzzles in any tall building.
Okay, so let's really think about this for a second. You've got a swanky high-rise condo, a super sterile hospital wing, and a buzzing corporate office. I mean, they seem like totally different worlds, but their entire flow, their function, even their bottom line, it all comes down to one single make-or-break factor.
And that choice? It's where you put the elevator. It sounds so simple, but get it right and the building just works. It breathes. Get it wrong, and that building suffocates from day one. So, in this explainer, we're diving into the hidden science behind putting that box in exactly the right place.
We all feel like we know elevators. You push a button, you wait, you get in. Pretty straightforward. But let's start with an experience that I guarantee every single one of us has had.
Yeah, of course you have. We all have. You're standing there in the lobby, staring at the numbers, tapping your foot. You start wondering if it's broken. Maybe you should just take the stairs. It's just one of those universal modern frustrations. But what if I told you that wait is a sign of something much, much bigger than a simple inconvenience?
That's right. According to detailed analysis from engineering specialists like Novin Puya Elevator, that long, frustrating wait is actually a symptom of a deep, fundamental design flaw. A badly placed elevator system doesn't just waste your time. It hemorrhages money and operating costs, it creates daily logistical headaches, and it can even compromise the safety of everyone in the building. That annoying wait? It's just the tip of a very large and very expensive iceberg.
So, to really get why this is so tricky, we've got to look at the invisible rulebook that controls every single elevator. Before an architect even starts sketching, they're trapped in this dense web of regulations.
And it's like they're serving two masters. On one hand, you've got your local municipal regulations. This is stuff from the city, how tall the building can be, where the fire escapes go, that kind of thing. It shapes the building's basic footprint. But on the other hand, you have these incredibly strict technical standards. These are often global safety codes that dictate every tiny detail about the elevator itself.
And when I say detail, I mean the level of detail is just staggering. A standard like EN 8120 isn't a friendly suggestion, it's the law. It tells you, down to the millimeter, how much empty space you need above the elevator car at the top or how deep the pit needs to be at the bottom. And why? To create a safe space for technicians to work and to make sure that machinery runs flawlessly. You literally can't just squeeze an elevator into a gap. You have to design the perfect space around it.
Okay, so you've got this mountain of rules. How do designers actually solve this puzzle? It's not about just finding a blank spot on the blueprint. No, it's a strategic step-by-step mission.
The process is super methodical, and you know what? It all starts with data. First, they analyze traffic. Who's going to use the building? How many people during that morning rush? Based on that, they pick the right type of elevator. Then, and only then, do they find its perfect home on the floor plan, create those hyper-detailed drawings, and finally bring in all the other teams, structural, electrical, you name it, to make sure it all plays nicely together.
And that last step, that coordination, it is a massive balancing act. Think about it. The elevator has to be right in the middle, easy for everyone to get to. But it also has to be near the stairs for emergencies. It has to fit into the building's skeleton without hitting a major support column. It needs its own power and ventilation. And if it's an apartment building, you better believe it needs some serious acoustic insulation because nobody wants to hear that thing rumbling up and down all night. It has to serve everyone without bothering anyone.
Now, for decades, solving this incredibly complex puzzle was a slow, painstaking manual job. But the tools architects and engineers use have gone through an absolute revolution, completely changing the game.
The old way was all about 2D blueprints, basically flat maps of each floor. An architect would draw the elevator shaft on their plan, and then a structural engineer would have to literally lay their own plan on top to check if, say, a giant steel beam was cutting right through the middle of it. It worked, but it was slow and oh boy, was it easy to make a mistake.
Today, everything is moving to what's called Building Information Modeling, or BIM. And this is so important, it's not just a pretty 3D picture. A BIM model is a complete, data-packed digital twin of the entire building. Every single part, from a tiny screw to the massive elevator motor, exists in that model with all its real-world information attached.
The benefits are just huge. Everyone, the architect, the engineer, the elevator specialist, is working on the exact same digital model in real time.
But the real magic, the absolute game changer, is something called clash detection. The software basically becomes a watchdog. It automatically scans the entire 3D model, 24/7, and flags every single conflict, like a ventilation duct trying to occupy the same space as an elevator rail. Problems that used to cause catastrophic delays and budget overruns on the construction site are now found and fixed with a single mouse click long before anyone even breaks ground.
All right, let's bring this out of the computer and into the real world. Because the theory is one thing, but different types of buildings present completely different puzzles that need to be solved.
This is where the rubber meets the road. So take a luxury apartment building. What are the biggest worries? Noise and space. You can't have a clunky motor room eating up valuable real estate. The solution? A gearless machine room-less, or MRL elevator. It's compact, efficient, and almost silent. Now switch gears to a hospital. Here, the top priority is moving large stretcher beds quickly and cleanly. So you need oversized, easy-to-sterilize elevators that are totally separate from the ones the public uses. And in a giant office tower, it's all about surviving that 9 a.m. rush hour. The solution there is a brilliant system called Destination Control. You just punch your floor into a keypad in the lobby, and it tells you exactly which car to get into for the fastest possible trip with the fewest stops. See? Each building, a unique problem. Each one, a tailored, high-tech solution.
So when you put all of these pieces together, the strict rules to strategic planning, the incredible technology, and these real-world examples, a completely new picture of the humble elevator starts to take shape.
So what's the big takeaway here? I think the experts at Novin Puya Elevator summed it up perfectly in their research. This isn't just a design detail. Getting the elevator right is a direct strategic investment in the building's future. It makes it safer, cheaper to run, and a fundamentally better place to be.
So, the next time you step into an elevator and the doors close, just take a second to look around. You're not just standing in a simple box. You're standing inside the result of thousands of hours of planning, problem solving, and incredible precision. You are inside the very heart of the building, the circulatory system that gives it life and allows it to reach for the sky.